Hello, and welcome to the third video in this Plan.City London how-to series, where we'll be talking about how to work with the various data layers present inside the app. We call data layers to those different datasets that can be overlaid on top of the 3D model of London, allowing you to visualize them in context and provide greater insight into the city in front of us. As we saw in the previous video dedicated to changing the time of day, accessing any of these data layers can be done through the main menu bar. To do so, please ensure you have access to the mouse cursor, something enabled at all times when controlling the app through the orbit pan zoom method or by clicking the escape key when using the drone mode. Once that's sorted, proceed to click on the Data Layers button at the lower left corner of the menu bar to bring up a panel listing all of the different available options. The ones we'll take a look at today are the 5 initial available ones released alongside Plan.City 2.0: London Boroughs, Future Skyline, Protected Views, Viewing Corridors, and St. Paul's Height Grid. They each share many common attributes, so let's start taking a look at the first one and make our way through the rest of the list. Starting with the London Boroughs, this is the dataset that will allow us to visualize the boundaries of each of the 33 administrative areas that make up the City of London. To do so, we can click on any of the buttons present in this sub-panel, something that will spawn the appropriate mesh for the selected entry, allowing us to see where its limits are on top of the 3D city model. The newly visible shape is displayed using a pink translucent material that contrasts with the white background buildings, as well as a black outline snaking through the ground in those areas where the borough boundary meets the terrain. We can select as many entries as we want, or simply select the Toggle All Boroughs option whenever we want to see or remove all of them in bulk. With so many of them visible, it can be a good idea to select the Display Name button, something that will reveal the names of the boroughs as well as their limits. And if scrolling becomes a chore, make sure to simply type the name you are interested in using in the editable text at the bottom of the list. The next data layer we are going to be talking about is the Future Skyline one, a proudly curated AccuCities creation, something we've done ourselves. This dataset combines our efforts of mapping out the different buildings that are set to appear in the City of London over the coming years, something that you have access to through this panel. Upon opening it, you'll be greeted to a slider that you can use to reveal the buildings that are set to appear in any given year. Not all of them have a specific completion date yet, so make sure to click on the Toggle TBD button if you want to view those entries. Beyond checking out their appearance, the app also allows you to retrieve specific information for each of those entries, something you can do by clicking on either of the icons present above the Future Skyline buildings or on the buildings themselves. Doing so will fill out the bottom part of the Future Skyline panel with information regarding the name of the development, its address, its status, or the different parties involved in its design and construction. On top of that, you can also click on the Filters button to see the information presented throughout the city. Useful if you only want to focus on building under a specific status, under construction, completed, or those whose planning has been granted. Moving on to the next entry of the list, the Protected Views dataset. This is a data layer that is very dear to me as it allows us to overlay real-world pictures on top of the virtual model, showcasing the degree of accuracy of the models we produce at AccuCities. These pictures have been taken as described in the LVMF document, short for London View Management Framework. This text describes certain specific views scattered across the city that are subject to special protection, and we've commissioned and included all of them in the app so that they can be checked within the 3D environment. Doing so can be done by selecting an entry from the list displayed in the panel, or by typing its name on the search box at the bottom. Choosing an entry will automatically move players to the location where the real-world camera was located when the picture was taken, and overlay that image on top of the model. It is at this moment when the panel changes and gives us the option to control various aspects of this visualization. Perhaps the most important one is the overlay opacity slider, something that will allow us to adjust the opacity of the real-world image, enabling us to see more or less of the virtual environment. These can be especially useful when used in combination with the Runtime Importer or the Building Sketch tools. Feel free to bring one of your designs into the app and check whether they can be seen when using this data layer. On top of that, other controls available in this panel are the Field of View slider, something that controls the field of view of the virtual camera, allowing you to zoom in or out. The real-world image immediately disappears when you adjust the field of view setting and can only be re-enabled when resetting the value to its starting position, something that, incidentally, can be done through the reset button that appears whenever the field of view slider isn't at its default state. You can also access other protected views straight from this panel by clicking any of the arrows next to the name of the image at the top, or access other images from the same vista using the sub-image controls below them. Also, a third slider might be available for those views that conform to a path as described in the LVMF document. Such is the case for view 22A, as seen here. Using that slider will allow us to move the camera along the path the official document has prescribed. The next data layer we are going to work with is the viewing corridors. This data layer has its origins in the same document mentioned before, the LVMF. However, instead of focusing on the vistas described in it, this entry explores the different height restrictions also described there. These restrictions apply to a subset of vistas, and we can toggle the geometry that encapsulates these limits by choosing the entry from the list in which we are interested. We can search for individual entries using the text box at the bottom of the panel, or toggle all of them at once using the Toggle All Corridors button. On top of that, the panel also gives us the option to switch between two materials for visualization purposes through the Toggle Transparent Materials button. The default opaque shader is probably best at seeing which bits from the buildings inside the corridors stick out, whereas the translucent one works better in terms of seeing if a design falls completely within those shapes. The next and final data layer available today is the St. Paul's Height Grid. This is a data layer very similar in nature to the previous one, as we can also use it to visualize height restrictions, this time those around the famous cathedral. The controls are even more immediate this time around, as we only need to click on the Toggle Grid button to reveal the associated mesh. Just like when dealing with the viewing corridors, a translucent material can be toggled by clicking on the Toggle Transparent Material option, enabling us to see which buildings are completely covered by the mesh. The 5 data layers we've covered this far can work well in isolation, but there are times when viewing multiple sets at once can be of interest. For instance, what if we want to know which future Skyline building belongs to which borough? Plan.City allows us to do that thanks to a couple of buttons we've actually seen this whole time when looking at the data layers. They are the Keep Data Layer checkbox and the Thumb button. By default, Plan.City destroys a data layer when you select a new one. Changing that behavior can be accomplished through the Keep Data Layer checkbox. Just make sure that item is checked for the data layer you wish to keep before opening another one, and the app will keep it active. The other button, the Thumb one, will also allow you to keep the current data layer in focus, but this time by preventing you to accidentally change into another dataset instead. With this button clicked, you'll see that you get locked to the current action you are undertaking. To be able to change actions once again, simply click it one more time to unpin the panel. And with that, this brings us to the end of this video. All of these data layers we've mentioned thus far are part of the initial package available in Plan.City 2.0, but rest assured that more are set to come in the immediate future. Data layers are a powerful part of Plan.City, and we can't wait to hear what other data sources you're interested in implementing. Here is hoping that this video has been of help, and please check out our other ones for more insightful information regarding Plan.City. See you in the next video.